Hi everyone! Today, we're going to learn about Avogadro's law. This law is named after Amedeo Avogadro, an Italian scientist who proposed it in 1811, during a time when the idea of atoms and molecules was still developing. Avogadro's law states that at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of gas. In simple terms, more gas particles equals more volumes. Equal volumes contains equal number of molecules. This means that different gases will have the same number of molecules if their volumes are equal, provided they're under the same temperature and pressure. In example, 1 mole of oxygen and 1 mole of hydrogen at STP both occupy 22.4 liters and contain 6.022 times 10 raised to 23 molecules. This is known as Avogadro's number. Second one is relationship with molar volume. Relationship with molar volume. At standard temperature and pressure, 1 mole of any ideal gas occupies 22.4 liters. This is called the molar volume, and it's very useful in stoichiometry for calculating gas volumes in reaction. Connection to the ideal gas law. Avogadro's law works alongside Boyle's, Charles, and Gay-Lussac's law to form the ideal gas law. When pressure and temperature are constant, the volume depends only on the number of moles. So if you increase the number of moles, the volume increases too, and vice versa.
Now, let's proceed to real-life application. Number 1. Balloons and airships. Imagine blowing up a balloon. When you pump helium into it, you're adding billions of tiny helium molecules. According to Avogadro's law, these extra molecules need more space, so the balloon expands. That's why party balloons get bigger as you fill them. Now, in airship, when engineers pump thousands of extra moles of helium inside, the gas volume increases so much, the whole ship becomes lighter than air. Number 2. Underwater diving and respiratory equipment. Scuba divers breathe underwater using their tank that holds a huge amount of compressed air, way more gas molecules than you find in a regular room. Why? Because deep underwater, the pressure squeezes the air, reducing its volume. Avogadro's law reminds us that to breathe normally, divers need that same number of air molecules expanding in their lungs. So, tanks pack extra molecules into small spaces. Hospitals use this too. Oxygen tanks deliver life-saving air by storing massive amount of gas in compact cylinders. When you inhale, the molecules expand to fill your lungs. Number 3. Industrial chemical process. Factories create ammonia for fertilizer by mixing nitrogen gas and hydrogen gas. To make this efficient, engineers pump extra molecules of these gases into the reaction chamber. And all those added molecules increase the gas volume inside, pushing the gases closer together. This forces more collision between particles, speeding up the ammonia production. Without this, we couldn't grow enough food. Number 4. Vehicle safety system. During a car crash, sensors trigger a chemical explosion inside the airbag. This reaction produces about 60 to 80 liters of gas, but in just milliseconds. Avogadro's law makes this possible because the explosion creates thousands of new gas molecules all at once. Since the temperature and pressure stay constant in the tiny space, all those new molecules desperately need room. They violently expand to fill the airbag, protecting you before you even blink.
So let's talk about role in the future. Number 1, clean energy. Hydrogen cars and green energy systems depend on storing gases safely and efficiently. Avogadro's law shows that more gas needs more space, helping engineers design the right size tanks This makes clean fuels and energy storage possible for a greener future. Second, space travel technology. In space habitats, every breath counts. Avogadro's law ensures that adding more astronauts just means adding more gas to keep pressure stable. It's key to designing safe life support system for Mars, the Moon, and beyond. 3. The medical equipment. Modern hospitals use gases in life-saving machines like ventilators and oxygen tanks. Avogadro's law helps them deliver the exact right amount of air for each patient. This means better care, less waste, and safer treatments. 4. Advanced material research. Creating advanced material often starts with tiny gas reactions. Avogadro's law lets scientists control gas volumes down to the molecule. That precision leads to the better batteries, stronger screens, and even self-cleaning clothes. Last, environmental protection. To fight pollution, we need to measure harmful gases in the air. Avogadro's law links gas volume to molecule count, helping satellites and sensors track smog and leaks. This data help clean our air and fight climate change.
So, I'm gonna show you our simulation. And I'm going to explain it using this game para mas lalo pa natin siyang maintindihan. First, to understand it more, have you ever blown up a balloon? The more hangin na ibublow sa balloon, mas lalo itong lalaki, di ba? Now, let's imagine sa loob ng balloon is my small particles called gas particles. Itong particle, we will count them in big group na tawag ay moles. So, moles ang gagamitin natin instead of gas particles. Sabi nga ng Avogadro's law, the more moles of gas you put into a container, kagaya ng balloon, the bigger the container needs to be, as long as the temperature and pressure stay the same. Let's see that in action with the simulation. Here, we see a balloon, 3 given with N, which means mole, and B1 and B2, which means volume. So, there's a formula on top, kaya ayun yung gagamitin natin to make the balloon expand or palitin. Now, how to play is need natin malaman yung anong number ang needed sa second mole. Kapag naglagay tayo ng number dito, lumalaki yung balloons. This show us what Avogadro meant. More gas particles take up more space. The game helps you practice until you find the right number and also help us calculate the Avogadro's law. Let's think of a real-life examples. When a car airbag goes up, it fills with gas. The amount of gas has to be just right to fill the bag without bursting it. So remember this one simple idea. More gas means more volume. If the temperature and pressure stay the same, the Avogadro's law. And now, thanks to this simulation, you've just learned it in a fun, visual way. Thanks for learning with me, and now let's all try to get a high score in the game.
So first, we're going to present to you our simulation about Avogadro's law. So, as you can see here, we're going to press start button. Then, there's 3 given, the first mole, second volume, and first volume. So, there is a formula which is second mole equals first mole multiplied by volume 2 divided by volume 1. So here, for example, 4 times 16. So it's 240 divided by 20 is 12. So let's see if it's right. Correct. So that's the purpose of our game, which is to calculate the second mole of Avogadro's law.
Start the game here. So this is the formula. So compute. So there's a P given, the mole 1, volume 1, and volume 2. Try it. Yeah. And divide it to volume 1.
Then
Then use the formula to compute the given.
alright.
Until maubos yung oras.
Tapos na.
So, what do you think about our game?
It's fun, but ang gusto ko lang is like parang meron kayong calculator dito sa digit. Tapos ilalagay nyo na lang yung mga given na nakatype to. Tapos yun ang mag-solve ng
Thank you. Thank you.